Welcome to another edition of Math for No Reason. So let P be a prime and J is any integer between 1 and P minus 1. We have to show that PCJ is divisible by P. Now, to do this, note that PCJ is P factorial divided by J factorial into P minus J factorial. We begin by noting the fundamental theorem of arithmetic, which tells us that any positive integer n can be written as P1 to the power R1, P2 to the power R2, Pk to the power Rk, where P1, P2, Pk are primes and R1, R2, Rk are natural numbers greater than or equal to 1. And this representation is essentially unique but for the permutation of the primes. Now, the key observation is that the primes P1, P2, Pk all divide n. If n is prime, the only representation possible is n equal to n to the power 1. There is no other positive integer between 1 and P minus 1 which would divide this number n if n is prime. This is the key observation that we will use for this problem. Now if you look at J factorial, this is J into J minus 1 up to 1. And all of these numbers are less than P and they do not divide P. We claim that P does not divide J factorial. Now to prove the claim, suppose P divides J factorial. This is the symbol of division. So P divides J factorial. So we can write J factorial as U times where U is a natural number. Now this means that at least one of these quantities must divide P. However, that is not possible since P is prime. So we have arrived at a contradiction. So P doesn't divide J factorial. Again, when we look at P minus J factorial, this is P minus J into P minus J minus 1, etc. up to 1. And all of these numbers are less than P. So they do not divide P because P is prime. So P doesn't divide P minus J factorial. Now rewriting this expression, we see that LHS is divisible by P. J factorial and P minus J factorial in the RHS are not divisible by P. That leaves us with the only possibility that PCJ is divisible by P. That proves our result. Thank you.